Alright, problem number 16 in group theory. Let G be a group and let the automorphisms of G denote the group of all automorphisms of G. If G is in G, the inner automorphism associated to G is the map sigma sub G from G to G by sigma sub G of X equaling X conjugated by G. So part A, prove that each sigma sub G is in the automorphism of G. This is equivalent to what we did in the very first problem that I posted, which we can go to quickly. The very first problem looks like this, and it's essentially the same exact proof. So what I've done is I've wrote the proof out, and I'll narrate it, and then B is new, so I'll talk about B. So again, we've done this before, but you start with just defining what we're talking about, claim it's an automorphism, show that it is a homomorphism with the same trick that I used before, where you include this identity element as G inverse G, which gives you these conjugations. Then you want to show injective, so you suppose two elements map, two different elements, you suppose that they map to the same thing, and then you show that X and Y are equal, again by the same logic I used in the first question. And then surjectivity, same kind of element that I choose for surjectivity works, where we want to get rid of the G inverse with what the property does, which puts a G on the outside, and similarly with the G inverse, and we have that as an automorphism. Okay, part B, this is the new part, prove that the collection of all inner automorphisms is a normal subgroup of the automorphisms of G. Okay. So we're showing that essentially sigma sub G is a normal subgroup of the automorphisms of G. So what we'll do is we will let sigma sub G be in the inner automorphisms of G, and phi be in the automorphisms of G. As well as, and we'll pick an element in G called X. Okay, and we want to show normality, so consider we're going to conjugate sigma sub G by phi. And we're going to look at the conjugation about X. So let me add some notation for this. Circ. Okay, and we want to show that this guy is still in the inner automorphisms. That if we conjugate by something in the automorphisms of G, we end up with something still in the inner automorphisms. And we know that this is equal to, we have phi of sigma sub G of phi inverse of X. And we close our 1, 2, 3 parentheses. Okay. And we're going to use the property of sigma sub G, which in this problem just conjugates by G, to get, by definition of sigma sub G, we have this guy is equal to, phi is still on the outside, but we get G times phi inverse of X times G inverse. Okay, we have that phi is coming from the automorphisms of G, hence it's a homomorphism. Since phi is a homomorphism, we can separate this G, this phi inverse of X, and this G inverse. So we take this guy, and we can write this as phi of G, lowercase g, times phi of phi inverse of X times phi of g, and I'm going to put the inverse on the outside here because we have homomorphism, so we have that equality as well. Okay, but we also notice we're taking phi of phi inverse, which is just x. They cancel each other out. So the final thing we have over here is phi of g times x times phi of g inverse. Okay, but we notice that this is just sigma sub phi of g, which is in the automorphisms of g. So notice that we'll take this last guy, is equal to sigma sub phi of g. I'm going to put that in curly brackets, of x, which is in the inner automorphisms of g. Therefore, the inner automorphisms of G are a normal subgroup to the automorphisms of G. And we're finished with part B.